if we're ready for that. Okay. So Aura was developed for Chrome OS UI. Originally, Chrome OS started out its life, so it's a Linux build of Chrome, sort of, and then it evolved. They wanted to change a bunch of UI around. It was originally just a browser window, but then they wanted to do more and more. And at some point along the line, I said, well, let's try and consolidate some of our UI with Windows. And so the first crack at that was a GTK port of Views, which Elliot loves. It's his favorite thing in the whole world. And every time I mention it, it fills his heart with joy.
Wow, Ben. I'm full of hate right now.
Yes. But that still relied on the fact on Chrome OS that there was an X window manager at the outer level that would manage this single or maybe a couple of Chrome windows and just sort of slide them left and right when you press Alt-Tab. And so the neat thing was that the content of the browser window, all of the views within that, that code was all the same as Windows, so that seemed promising. The crappy part was that the window manager was in a different process and lived in a different repository even, and it was hard to change. And the GTK port of Views was done by, I think, Scott Violet and Brett did a bunch of work on that, and they weren't really GTK aficionados, and I don't think it was that great a thing, or there were some fights between the different frameworks. And GTK's role in life is effectively similar to Views, so it's kind of weird to have that kind of duplication. And
there are constant problems with the two of them fighting over focus, fighting over events, and especially targeting and making sure that events were sent to the correct place. It was just badness all around.
So anyway, in 2011, I think it was, some of the UI designers began to come up with some new ideas for Chrome OS, especially as Chrome OS moved beyond the ultra low-end hardware into stuff that could maybe support running more than one browser window at a time, into more window management. And there was a lot of ideals about what kinds of window management we might have, but I think one of the earliest inputs into this was that the devices are still going to be very constrained, but they'll have reasonable video hardware. So the window management should be hardware accelerated, or at least so that we can do large-scale transitions. We want to be able to move lots of pixels around really, really quickly. And so I mentioned before about some of the early prototype work that was done in Waterloo on adding the ability to hardware accelerate parts of a view hierarchy. And they'd done some experimentation around this and were trying to come up with a functional kind of desktop Chrome environment based on that. But there were some challenges that they ran into. One is that in Chrome code, there's this fairly pervasive notion of a GFX native view and GFX native window. Now on Win32, those are the same thing. There's just an HWind. On Mac, I think there's like an NS view versus NS window in Cocoa, and on GTK, there's GTK window versus GTK widget. But anyway, there's a lot of code in Chrome that doesn't depend on views explicitly because it's lower level than views, but that expects the platform to provide it with some kind of native widget to render into. And so content, for instance, the class there that actually renders the content, render widget host view implementations, they take there will be some platform-specific implementation that actually bitblitz to a HWind or whatever else at various points in time. But then the code to actually provide that HWind through to that code, there's a lot of wiring, and so there's this platform type def of native view, native window that wires its way through all of these interfaces, and it wasn't easily possible to send a view through there because the place that type def those things was at a lower level than views. We could move views lower down the stack, but views is kind of this big beast, and it seemed like there was maybe a simpler way of going about this. So at this point, I began to think, what if we took So Window Manager doesn't really need all this functionality that Views has. Like, it doesn't need like buttons and other stuff. It just needs a window type that we can map native view to, and it needs a layer so that we can move it around with accelerated transitions and some other properties. And so that's where Aura came in, so that there's just a single window type that has those things on it. And so it's very similar to views in that the structure is there's a tree of windows, and the windows have disposition properties, and there's event handling and dispatching that goes through the tree. Paint processing is actually handled by the layers. The compositor knows when stuff is, or you tell the compositor that stuff is dirty. And Aura doesn't really do much tracking of that. But otherwise, fairly similar to views. And then the idea then is that once we had this system, we could actually implement the window manager in process in Chrome. And it's just sort of like scraping off some of this. If we just scrape off that layer and put in our, or maybe just sort of move it aside, and then we can insert our own thing in between. And then we can trick all of the rest of Chrome by making sure that the GFX native view type def works or resolves to something. And then we can just make all the rest of it work. So that's how Aura came into being. So I covered a lot of this. So the intent of Aura, the Chrome OS team has conflated Aura with their UI a lot. So sometimes you'll hear them talk about Aura, and what they really mean is their window manager UI, which is actually Ash. Ash is, the name comes from Aura shell, shell in the Windows sense of, all of the different taskbar-like things and stuff like that, not the terminal sense. Early on in the development of Aura, I kind of resisted the temptation to add a lot of window management stuff to it. So Aura is actually, the objective for Aura is that the window type is really lean. There's still maybe more window management stuff in there than I would like, but almost all of the window management stuff has been punted to Ash. There's a couple of things on, like the concept of whether or not a window is active. It's a tempting thing to put on a window, but manage to keep that out of there in a separate place because your activation rules are kind of intricately related to how your window management system works. Stuff like that, and various other things. Like it would be tempting to add functions to maximize a window or restore a window. And maximization is a feature of a window manager, not necessarily of the window type. I think this sounds similar to how X is intended. Like there's a bunch of characteristics of a window manager that are not necessarily carried with an X window. Those are more things that you can associate with it. Mm-hmm. You're nodding, so I'm assuming I'm correct.
You're more or less correct in this case, except that the window manager is just a ball of mud. Okay. Yeah, Ash is probably a ball of mud too. So. Tried to keep as much of that stuff out of Aura as possible. Aura has this thing called a client API. The reason it's called client is that content also has an API called client. The client API is what the person that uses the library implements. And basically the client API does things for Aura that it can't do itself. And so Aura knows a little bit about focus. And so it knows that there's this thing that will somehow achieve focus for it. And so there's a client API for code focus client that Aura can call through to say focus window or something like that. And then the thing in the window manager that knows what the implications of focus are will actually go and accomplish that task for it. The client API is also being abused a little bit. So it's a conduit between parts of the code that, so the structure, if I can erase this now.
You can throw on the side, I can move the
Oh,
camera.
okay. So if we look at some Chrome modules, like content, and then there's Aura, and there's Ash. And so Ash depends on Aura, and content depends on Aura, but content does not depend on Ash. So content has the render widget host view, and there's an Aura-specific version of that, render widget host view Aura. So that's why it's allowed to depend on Aura, or is considered sufficiently low level that content is allowed to depend on it. But Ash contains a whole bunch of other stuff that's not like used in various places. And so how would content go about achieving
certain window management activities like activating a window or something like that. So content, this is the hack part. There's this the client API there, so content will sometimes call through this out to it, effectively knowing that Ash is going to implement it. And even so, that's a little bit icky, but I haven't come up with a better solution to that yet. So there's some code that lives in the client API that doesn't exist to fulfill some need that Aura has. It exists just as a pass-through for people that don't know about each other to talk. It's kind of like an attorney. Or don't want to know about each other to talk. Another interesting component. So with the start of the desktop Aura project, I realized that there's a bunch of stuff in Ash that might be useful. Like whenever you have a set of Aura windows, you're going to have to deal with focus. And focus is historically kind of this nasty thing that no one really likes to deal with. And so there's a bunch of focus logic in Ash that dealt with how focus works. And so I figured out how to extract that from Ash and make that be usable by both Ash and make it usable by both Ash and the desktop Aura stuff. And so that set of utilities like focus and window modality, window shadow, some of the common window animations and utility functions and stuff like that. I created this little part of Views called Core WM, which is just the shared code between the two that is not specific to either of them. Focus and activation is very interesting. It's, like I said, fairly complex. Focus is the window that receives keyboard events, and the active window is the window that contains, it's the top level window that contains the focus window. It's often, although maybe not in every case, the visually topmost. You can have other windows on top if they're not focusable, potentially like tooltips and stuff like that. In Aura, the Core WM focus controller is the thing that implements focus handling. But focus and activation are closely related to each other. So it also handles activation. So there's two client interfaces, two Aura client interfaces. One is focus client and one is activation client. And those interfaces have methods for like focus this window or activate this window, and the ability to get the focus window and to get the active window. And so a lot of effort's been put into this focus controller to keep it kind of the simplest possible thing. There used to be a lot of special cases and weird edge cases because we didn't understand what the ramifications were for focus changes. So I've tried to understand a lot of this, and since I haven't touched it for about 9 months, I've promptly forgotten. But anyway, there's at least a lot of unit tests. So if you have to deal with focus, that's where you'll find them. The focus controller, like I said, it implements the activation client, focus client. So any attempt to focus or activate a window will go through it, and it will try and validate the window that you're trying to focus or activate. It may be that the window that you're trying to focus or activate cannot be because of some other condition. An interesting example of this is that in Ash, running on Chrome OS, you could have a web page that calls focus on itself, like it tries to activate itself. And especially if it tries to focus itself, this would cause Aura to want to like dispatch key events to it. But if your screen is locked, we don't want to do that because we want the lock screen to stay the focused window. And so there are window manager specific rules that apply to what gets focused and when. And so attempts to focus or attempts to activate run through those focus rules that will try and find a valid focusable and a valid activatable window in those cases. So a window has to be focusable, and a window has to be focusable to be activated, to be focused, and it must be within an activatable window because of those properties that I said earlier, where the Focus window is the window that receives key events. The activatable window, the active window, is the window, the top-level window that contains the focus window. So the focus window must be inside a window that is activatable. Otherwise, it can't be focused. I actually have a doc on chromium.org somewhere that explains a bunch of this in detail. Another interesting example of this, and let's see if I can create some more space here, is if you have a modal window. You might have some, imagine this is your browser window. Here's my tabs and stuff like that. And I open the bookmark editor. Here's my bookmark bar. And the bookmark editor is modal to the browser window. So if I open this bookmark editor here, if I click here, I shouldn't be able to activate that window again as long as this one is active. And so the focus controller will interpret clicks to this window and say, like, this might be the content area, so this is actually a child window of the browser frame. And it will be like, can I focus this window? Is my top-level window, this guy, activatable? No, because this one is modal to it. So then it will say, instead, that this window is the activatable window for this child window. And because this activatable window and this child window are in different trees, it knows not to focus that window because it's not inside of the active window. And stuff like that. There's a whole bunch of interesting things like that that take place. So Ash has very elaborate focus rules for these various situations. In the desktop Aura case, the focus rules are somewhat simpler, but that's generally the gist of why that abstraction exists. On the view side, this is something I didn't mention covering views. There's also a focus manager there, and that focus manager handles focus within the view hierarchy. Like assuming that the native widget Aura that contains that view hierarchy is focused, within that view hierarchy, which view has focus for view's key event dispatch. So it tracks focus view and saving and restoring focus when that view's widget is activated and deactivated. Handling tab traversal within controls within that window, and things like processing accelerators and stuff like that. So I've talked a lot about events. I should mention events a bit here. Event dispatch is pretty complicated in its own way. With Aura, we developed basically a copy of the view system, although it was different in some ways. But that was unfortunate, and so we decided to consolidate the event dispatch for both Aura and views. And so Sajrul and I worked on this set of changes where we extracted event dispatching out of both into what's now UI events, source UI events. And so there's a bunch of interfaces there. There's a notion of an event handler. An event handler is some class that is told that an event happened. There's an event target, which is something that can receive events, which is either a view or an Aura window. And then there's an event dispatcher, and the event dispatcher is responsible for basically dispatching an event to some target. So what will happen is that the root view or the root window on the Aura side will receive some platform native event, and it will construct a UI event out of it. The Aura root window or the root view will figure out what window or view to target it at, and then it will call into the event dispatcher, and then that will send it down the tree. And then that code is shared between them. So there's some notion that there are different types of event handler. The model is similar to DOM events in that you're given a target, and the dispatch works from the root all the way down to the target, kind of like the capturing phase in DOM events. And then it'll be handled at the target, and then the event will propagate back up, similar to the bubbling phase. These are called event phase pre-target, event phase target, and event phase post-target. The reason for having these separate phases, this didn't used to exist in either Aura or views. The reason we wanted to implement this for Aura is that I wanted window moving, implemented by the window manager, to be implemented after the window had a chance to handle and potentially consume the event. And this is to match Windows behavior. On Win32, you receive a message. Windows will send you the message before Windows tries to
start moving the window itself. And so as the implementer of the app, you have the opportunity to cancel the default move operation by just not calling diff window proc. And so I wanted to provide similar functionality here, that basically you could say, like DOM events, you could say stop propagation. If I'm doing something else or I want to write code myself that handles moving differently to how the window manager would like to do it. And so that's why this was set up. So a lot of the Ash functionality, window management functionality, it basically just event handlers that are set up to observe different events that are dispatched into the root views in the Ash system. So window moving, there is a post-target event handler attached to the container of all of the movable windows that monitors for like mouse drags, mouse down, mouse move, and mouse up, and so on. And if the Chrome window that you're moving doesn't do anything to stop the propagation of that, then it will run the move loop within Ash. Some of the Ash event handlers happen beforehand, like they consume, like the focus system. Or the Ananta has experienced with this recently. The modality system wants to be in first and grab that event and do something before anyone else gets a chance to do something with it. So it just depends on the feature as to if the event handler is hooked up to handle events before or after the target gets it. And you can hook up an event handler on any window or view above the target, and it will get a chance to inspect the events that come through it on its way down to any target contained within it. So that's kind of an overview of the event system. So I don't know if we have any questions about Aura or events, just before I talk about some of the examples.
So like in Aura, when you put the mouse around there and then click the mouse, so it goes through the H1 message handler down to the root window host and then to the root window.
Yes, actually, so this is something I didn't cover. Thank you for bringing this up. On the Aura side, we have somewhat similar arrangement to this. It's just that all the class names are different. So there's a root window. And then you have your window hierarchy. And then there's, much like Native Widget, there is this interface called root window host with various platform implementations here. And so desktop root window host, Win, or desktop root window host like X11, or whatever. Oh, is it Linux? I can't remember what the suffix is. Aura X11. And so your native event comes through here, and basically in here they create a UI event which gets passed through to here and then is dispatched into the tree, much like on this side.
So there is one question on window and view.
Mm-hmm.
I'm a little confused about how the window and view relate to each other.
Okay, this is a good question. So let's just think about Chrome OS for a moment. In the Ash environment, there's a root window host, RX11 out here somewhere, and then a root window, and then a hierarchy of windows within it. One of these windows is a Chrome window. Let's just say it's this one here. Bound to this is a native widget Aura. A native widget Aura has a Aura window, and then there's an embedded view hierarchy within it. And so one way to think about it is that windows all have layers, and so the transitions that apply to them are accelerated, and it's sort of hardware accelerated rendering, whereas the content of the window is software rendered, although we might make it, insofar as Skia eventually becomes fully hardware accelerated 2D as well, but that's just one way of thinking about it. So views provides the content of a window, whereas window provides the kind of window type, the outer most thing.
Outer shell.
Yeah, yeah. So like there would be a nested view hierarchy within this. I could draw a big picture on here, but I'd erase all of this, and then the dialog will.
So the hierarchies are not parallel; they're nested.
Yeah, they're nested.
You can erase if you want.
Sure. Oh, sure. Let me just do this then. I'll try. Maybe I should use colors.
so that the different frameworks have their own colors. That might make it easier to understand. So I'll use this for Aura. So you have your root window host X11, and there's a root window. We have some arbitrary hierarchy here, and these are windows. And then we go into views land. We use green for views. And so over here and erase some more of this because I'm going to make this even more interesting.
Does that mean all child views actually share the same aura window in that tree?
Yeah,
Okay.
yeah. These all render to a canvas that basically forms the content of the. There's a texture for the Aura Windows layer, and these all render into it. An interesting example here is, let's say this is a browser window and this is actually a web view, and so there's a web contents in here. There may be another Aura window. If this is there's a native view host or something like that for the web view. And then this guy is actually, I'll draw a solid line because it's no different, is a child of that one. But this native view host here is basically responsible for positioning this Aura window relative to this one, such that it matches this view's position in this hierarchy. So,
Can you repeat that last part?
Okay.
So aura window.
So if this widget is a browser window, and our content area, from the content API, there's web contents, and the web contents wraps a render widget host view Aura. The render widget host view Aura itself has an Aura window. That's this Aura window. So this would be embedded in this view hierarchy. Like, let's say this is your browser window and here's your tab strip or whatever else. And this one here is the native view host, which is a views type that I talked about earlier. This would be bound to the Aura window provided by content. And so this view here this view has some position, some bounds within the window. Like it's offset by, here's my content area. And then
Because of the layout manager.
Because of the browser window, there's a tab strip and Omnibox and stuff like that. And so that there's actually some X and Y of the content area from, this is one Aura window 1 and this is Aura window 2. There's some X and Y offset here, but that position is the total offset between this view and the root view, which is at 0, 0. So this guy here knows to position this window at that, so that it's
Observation for that. Yeah. Could it have been a view instead?
Because
Yeah, I mean, shouldn't it be possible in theory to just have one window and then have just everything else be a view?
because Aura is lower level than views.
content doesn't depend on views.
Because of this diagram.
What was the name of the view?
Native view host. So yeah, and so some of this pattern is actually not new with Aura, because we used to do this with HWinds as well. When we had child buttons, like we had a native button embedded in our hierarchy, of course Win32 knows nothing of our view layout, so we couldn't just say that this button was like small X and Y offset from this guy. We'd actually have to say it was offset from the parent HWind. So it's kind of analogous to that. Yes, it's confusing that there's two types. And I'll get to that more when I.
Content not depending on views, is that a historical thing? Or
Yeah.
is it,
It's both. It's a historical and active preference. Just because views is, it has a whole bunch of stuff in it that content doesn't need to know about. And in general, we like to keep the dependency tree of of any component, like as limited as possible to just the set of functionality it needs to know about. And then that makes it easier. Also, it means it's easier for us to change views because we don't need to worry so much about breaking content. You have to be slightly more careful changing Aura because you might break content. But Aura is much simpler, so it's more obvious what the effects of your changes
Would it be possible to like abstract the notion of an area that you can draw into like a common interface?
Yes. Yes, it should be.
So now that we're talking about that, you probably want to mention the compositor. I think it's attached to the root window.
Yes, and so I mentioned briefly earlier when I was talking about the history of all of this how we had a different compositor in the browser, and so then we developed this layer type and UI compositor, and there's a whole bunch of utility functions and so on in there. At some point, the compositor guys that were working on web engine compositing felt like it was, again, wasn't a great idea to have two compositors, and that actually on Chrome OS for a large set of for some set of devices that we want to support, it's actually detrimental to have two because you end up compositing the web content and flattening it into a texture, and then you have to read all of those pixels back in the browser process, and then composite them again, and that's slower than just doing a single composite. And so ideally there would just be one compositor for both the content area and the browser UI. And even though we've only got there recently, the first step on that path was to not use a completely different compositor in the browser. And so at some point over a year ago, Antoine changed the UI layer type, which we still use, to just wrap a CC layer, which is the master universal compositor, the Chrome compositor. And so UI compositor it's kind of interesting now. It's not even really a compositor. It's just a set of syntactic sugar on top of CC that views and Aura talk to. And so eventually it could maybe either go away or like some of that functionality could move down into CC or some of it could move up into some higher layer and it could cease to exist, but that's the reason for it. But anyway, yes, on your root window host, I believe, we have a compositor set up. There's the layer tree host, basically. I'm going based on, I talked with James and Antoine a bit recently about how all their stuff works internally, but the compositor is effectively encapsulated by this layer tree host that is this thing that hosts a tree of layers. And so there's a layer for each window within that. And then optionally for views can have layers too, which makes the hierarchy a little, maybe if I draw layers in here, you have your layer tree host. In UI land, this is UI -- compositor. And so this has a layer, this has a layer, this has a layer, and this has a layer. And so the hierarchy here is child, child, and child. And then just to make things crazy, like I said before, views can have layers too. So that is also true.
How long is that going to be true though? Like if this isn't being used, shouldn't we just like rip out the
Maybe.
ability for a view to have?
Maybe. I can't guarantee it's not being used. I have to look. I can't remember seeing its use.
Yeah, if we want to accelerate the spinner or
It
the
needs to
icons
be a
on the
view.
tab, it needs to be a layer.
So we set it up as a layer and then just set a rotation transform on it.
There's some precedence for individual views being able to have layers for accelerated effects in UI toolkits. I think Coco does this. You can say that a particular NS view has a layer that allows you to, that basically allow certain property changes to be accelerated. It's not without precedent, although I agree if there's, in general, if there's complexity that's not being used, we maybe shouldn't have it. But I'll comment on that some more with some of my future opinions.
So animations and all are part of the layer?
Yeah, so, well, there's two different kinds of animations. There's some animations like tab strip reordering, for instance, or that hover highlight you get over tabs, or just like when you mouse over buttons and they light up, that kind of thing. Those are all non-accelerated animations, and those animations are just implemented in the view hierarchy by whatever wants to do those. The individual button view might run an animation for changing fading from one state to another or whatever else. But larger scale animations, like when on Chrome OS, when I minimize a window, the whole window goes and kind of rotates down into the launcher. So there's like a rotation, a scale, and a translate or something that all happen there. And so those operations are accelerated and happen on the Windows layer. And so the way that works basically is the composite, and you can look through the UI compositor directory. There's a bunch of utilities there like scope, layer, animation settings, and stuff like that, where you basically say, I have my current state, I have my state that I want to be at, so what the window is right here right now, and then when the animation is done, it's going to be minimized down here, and this is the end state. And the presence of the scoping, an instance of the scoping animation object, as soon as that falls out of scope, it will run an animation from here to here. And then it's super easy to do. And some of it's a little harder depending on how fancy you want your animation to be, but most of the common ones that are just scales, translates, and simple rotates are all really straightforward. Ian Volek in Waterloo is a wizard with this stuff. So if you ever have a really tricky animation that you need to get right, he can help figure out how to massage the system or how to use the system to do what you want. Yeah, that's that stuff. So layer has layer just has a bunch of property setters on it, and if there's an animator associated with it, those property changes will be animated, and if there isn't, they'll just be immediately set.
As a quick follow-up there, we do use that thing. We use it in Message Center, we use it in AppList, and Ash loves the heck out of this functionality.
Okay. Well then, I mean, I specifically at one point had in mind that it would be used, or there was a user for it, so I wouldn't consider it to be a wart, so it's fine if it's being used. I don't have any objections to its existence.
I have a slightly different question, but so if you take the words like render, widget, host, and view, and make every permutation of those words,
Yeah.
that's probably a class.
Yes,
So-
there's even I think Evan Martin wrote a tool that let you generate these.
So can you just like summarize the most important permutations and like why they're different? Because I always get confused.
Yeah, I completely understand. You really run out of names quickly.
Like,
So.
off the top of my head, there's like the render